we go. We have now our new lesson, so we will now discuss it. Let's talk about measures of variability for ungrouped data. Okay, we remember that measures of variability measures the degree of how spread out or clustered the scores in a distribution, and that the following measures are here: the range, the variance, and the standard deviation. Range represented by capital letter R, variance S squared, and the standard deviation is S, meaning it's just actually the square root of S squared. Okay, and let's look into how this range are defined, the variance as well, and standard deviation. So the range actually will just simply give an idea of how scattered or closer the scores from each other given a scores, set of data, and that you're going to study. You're going to check into how spread or how close the scores from each other. You can make use of the range by just getting the highest and the lowest, right, scores, and that sometimes we use the more reliable one, the interquartile, in which we can get it by getting the difference of the upper quartile and the lower quartile. And so we use the data, the result, to interpret how scattered or closer the scores from each other. Okay, the variance, this measures the average degree to which each point differs from the mean. Alright, it's an average degree, how these points differs from the mean. Okay, and that for the standard deviation, it's actually how spread out a group of numbers are from the mean. Okay, that's how simple it is. Let's try to look into how we can solve the following. Okay, we include here the different formulas. Okay, and this includes the mean score, which actually you have already encountered this one in your measures of central tendency. This is also your average or average score, right, where you see the mean is equal to the sum of your scores over the total number of observations. Okay, the sum of the scores over the total number of that scores or observation. You can get the mean or the average. So you have also the formula for the range. It's very easy. You have R is equal to highest score minus lowest score. And for the variance here, you have to be familiar with this one. S squared is equal to the sum of the quantity x minus the mean squared. Again, sum of the quantity x minus the mean score squared all over n minus 1. Okay, where n refers to the total number of observations, and here above the numerator you see the mean, how the mean is used. Okay, so it's x minus the mean squared. We will solve the variance that way later on. For the standard deviation, you can use this formula. S is equal to the square root of the summation of, or the sum of, the quantity x minus the mean score squared all over n minus 1. So you can see our variance is just being extracted. The square root is being extracted, then it becomes the standard deviation, and therefore you can get your standard deviation if you have already your variance. You don't have, or you cannot have, your standard deviation without solving first your variance. Okay, so let's continue. Now let's try solving for the first measure, solving for the range. Example data here from Ungrouped data. Scores in math quiz of 10 students in the section A. Take note, section A ito. And that we have the scores 12, 20, 34, 40, 10, 42, 30, 25, 20, and 28. Of course, finding the range is just by simply subtracting the lowest score from the highest score. So your highest score here is 40 and your lowest score is 10. So therefore you can get your range by subtracting 10 from 40, and so your range is 30. Okay, take note that's the range of the scores in that section A is 30. We'll try to check another data. For example, we have here data, still scores in math quiz of 10 students, but now in section B. Okay, in section B we have the scores 15, 20, 24, 30, 25, 16, 35, 30, 21, and 15. And then you are to find the range. Of course, you have to subtract the lowest score from the highest score. Here, in this set of data, your highest score is 35 minus your lowest score, which is 15. And so you have 20 as the range. Now let's compare. The range in section A is 30 and in section B is 20, which means section B, the scores are closer to each other compared to section A. Alright, it's more scattered. The scores are more scattered. This will give us idea how range is used as to interpret or give something the analysis to scores, row scores. Like for example, you were given just the range and you don't know the scores, you don't see the scores, and you were told that the range is just a small value. So if the range is smaller, then you can say or conclude that the scores in a given data are clustered together, while if the range is higher, the scores in the data are scattered. Okay, are scattered. So if the range is lower, clustered, okay, close to each other. If the range is higher, that means the scores are scattered. That's how we use the range, as we give an interpretation to how the scores behave in that data. Okay, solving for the variance and standard deviation this time. So that's the second and the third measure under the measures of variability. Okay, remember we're solving ungrouped data, so very easy. It's just very easy. Now let's use this data here. We have the following scores: 15, 20, 24, 30, 25, 16, 35, 31, and 21. Your first move or first step should be that you are going to solve first your mean score or the average. Now, you know how to get the average, right? You are just going to get the sum of these scores and divide it. How many scores are there? Yeah, we say we get the sum of the scores and divide it by the number of observations. Using the formula, and this is our formula for the mean score, the x bar is equal to the sum of x, where x refers to the scores, each of the scores, meaning all the scores now you are to sum up, and then divide it, how many scores are there, n refers to the number of scores or number of observations. So if you are going to sum up these scores here, given the data, 15, 20, 24, 30, 25, 16, 35, 31, 21, you add it all, it's equal to 216. Okay, 216. Therefore the sum of x is 216, where n is 9, because there are 9 scores here. So 216 divided by 9 is 24. Now take note, your mean score is 24, your average score. It's necessary that you can compute for the mean first before you compute your variance and standards, because this is where we base our interpretations. Okay, now Next step after computing for your mean is prepare a table, not the frequency distribution table, but a table like this, wherein you're just going to write all the scores in one column. So that's your x, the scores. And so in the second column, you will have the difference of every score and the mean score. Okay, every score and the mean score. So that's why we solve first the mean score, so we can use it here. Okay, so score minus the mean score, or the average score minus the average, somewhat like that. Okay, so all of the scores 15 down to 21 here, you're going to subtract 24 from that. So this is our mean. So we'll do it in each of the scores. So you have 15 minus 24, that's a negative 9. 20 minus 24, that's negative 4. 24 minus 24 is a 0. 30 minus 24 is a 6. 25 minus 24 is a 1. 16 minus 24 is a negative 8. 35 minus 24 is 11. 31 minus 24 is 7. 21 minus 24 is negative 3. So next column, you are going to do this. Your x minus the mean score, or the score minus the mean score, is to be squared. Okay, you have to square it, meaning our results here, our difference here, will be squared in this column. So 9 times 9, negative 9 times negative 9, because we square negative 9, that's positive 81. And you square negative 4, that's 16. And you square 0, it's still 0. You square 6, that's 36. You square 1, that's still 1. You square negative 8, that becomes positive 64. And you square 11, that's 121. 7 will become 49, and negative 3 becomes positive 9. Now, what's next to do after doing all the subtraction and then the squaring of the results? You are going to get the sum. Okay, that's why you have here in the bottom the sum of the quantity x minus x bar, or the score minus the mean score squared, is equal to, sum it all. You just add up all these numbers and then you will have an answer 377. So you write it down there in the bottom. Let's look into also the sum of x here, because this can be, it's important also because we are going to use this in our formula. The sum of x, or the sum of scores, is equal to 216. You simply add all the scores here. Okay, the scores that are here in this column, you add it all, that's equal to 216. Now your table is complete. You are now ready to compute or solve the variance and standard deviation. Take note, your standard deviation will be there, or easily solved or easily identified once you have your variance already. Okay, once you have your variance already. So solve for the variance and standard deviation. Okay, now let's use the formula. S squared is equal to the sum of the quantity x minus x bar raised to the power of 2 all over n minus 1. Okay, where the sum, this one, the numerator, the sum of the x minus x bar, or the scores minus mean score squared, is actually there in your table already. You have the sum now. Okay, so you don't need to keep on thinking what to substitute, because you can substitute right away our summation at the bottom. So this must be 377. And then, and here, since there are 9, it will be 9 minus 1. So that's why we have here 8. Okay, if you are going to count, there are 9 scores here. Okay, 9 scores. So that's what we applied here. And minus 1, that's 9 minus 1, that's an 8. If you are going to divide 377 by 8, you have now 47.125, or 47 and 125 thousandths. Okay, now you can now actually get your standard deviation. Your standard deviation is, of course, just extract the square root of what you have in the variance, result in the variance, because this formula inside the radical sign is the formula of the variance. As you notice, the formula of the variance. So if you're able to solve the variance already, that's the result. Now you just have to extract the square root. That will be your standard deviation already. And that when you extract the square root of this result 47 and the 125 thousandths, that is approximately 6.86. Again, the square root of 47.125 is approximately 6.86. So once you get the variance, you get the standard deviation. And take note, this 47.125 is, interpreted as to the degree, how far it is, or how near it is to the mean, the difference. Okay, it can be significant difference. And then you have the standard deviation. It will just tell you how some cluster of scores are scattered away from, or how scattered near from the mean. Okay, that's all. So yeah, I'd like to say thank you so much. That is just very short, and that I hope it helps you. If you think the video helps you, then click like, share, and then subscribe if you want to watch the next videos, continuation to the lessons that we have. Or you may click the bell so that you'll be notified whenever we have new videos. That's it, and bye bye.